Module 13.1 is volume of cylinders. Okay, so volume still is area of the base times height, but when we're looking at a cylinder, the base is a circle, so you're going to use the formula for area of a circle, pi r squared. Okay, so I'm going to write that out. So we're going to find the volume of each cylinder. So area is going to equal, volume is going to equal pi r squared times your height. Okay, so we have our radius and we have our height already given to us. So I'm going to say pi, my radius is 4 squared, and my height is 16. Okay, so I'm going to go ahead and simplify this. I'm going to take pi times 4 is 16, and I still need to take it times its height of 16. Now the first thing we're going to do is put everything with the answer of pi. So I'm going to take 16 times 16, which gives me 256 pi. I'm still taking that times pi. And Mr. Durfee may have you leave it in terms of pi. So you could have 256 pi centimeters cubed, or if you want to simplify it with pi being 3.14, we'll go ahead and do that. So take 256 times 3.14, and you get 803.84, and we're going to label that centimeters cubed. Okay, so we're going to go here, but we also need to understand we can leave it in the terms of pi also, because this means times pi. And since pi is a rounded number, this is an exact, or this is an estimate. This is an approximation. Okay, so if you need to find the exact, you leave it in terms of pi. Otherwise, you can use 3.14 for pi. So if we do another example, we're still using that same formula. So volume equals pi r squared, because that's the area of a circle, times the height. Okay, in this example too, we were given your radius of being 8, right here, right? So that's going to be times 8 squared, and then a height of 6. So if we simplify that, let's square the 8. So we have pi times 64 times 6. We can still multiply 64 times 6, which gives us 384 pi centimeters squared. Again, or cubed, excuse me. Again, this is an exact answer, but a lot of times you're going to have to find the approximation. So you're going to actually take the 384, we'll estimate pi at 3.14, put it in your calculator, and then we get 1,205.76, and that's still centimeters cubed. So that's our approximation. So that's how you find volume of cylinders. Let's go ahead and do your examples in your guided practice. So get out your books. Okay, so your guided practice starts on page 402 in your workbooks. First it says, vocabulary, describe the bases of a cylinder. They are two congruent circles. Two congruent circles. The next one says, figure 1 shows a view from above of inch cubes on the bottom of a cylinder. Figure 2 shows the highest stack of the cubes that will fit inside the cylinder. Estimate the volume of the cylinder. Explain your reasoning. So if you knew how many cubes are in the bottom, right, you could kind of estimate that. So 3 by 1, 2, 3, 4, 5, 6, 7, 8. So 3 by 8 gives you 24. And if that's 8, this has to be 6, right? So 6, 6, 6, and 6. 6 times 4. Maybe I counted wrong. 1, 2, 3, 4, 5, 6, 7, 8, 9. Whoops, sorry. It's by 9. So 3 by 9 gives you 27. And then you have 4 by 7, which gives you 28. And then you have 3 here and 3 here, so 6 more. So if you add those up, 27 plus 28 plus 6 gives you 61. So the area of the base, so volume is going to be area of the base times the height. Area of the base is about 61, and the height is 1, 2, 3, 4, 5, 6, 7. So we could estimate it at approximately 61 times 7, which is about 427 in their inches, so cubic inches, okay? So explain your reasoning. I took the area of the base, which was 61, times the height, which was 7. Okay, the third example says to find the volume of a cylinder to the nearest tenth and use 3.14 for pi. So volume equals pi r squared times height. So we have to fill in our radius, and we can see here that that is 6 squared, and we can see our height is 15. So 3.14 is pi, 6 squared is 36, times 15. So in your calculator, I'm going to take 3.14 times 36 times 15, and I get an answer of 1,695.6, and that is meters cubed. So the volume is approximately 1,695.6 meters, oh, there you labeled it, meters cubed. A Japanese okodali is a very large drum. Okodauko is a very large drum that is made by hollowing out a section of a tree trunk. The Museum of Takamala City has three odekos of similar size carved from a single tree trunk. The largest measures about 2.7 meters in both diameter and length and weighs about 4.5 metric tons. Using the volume formula for cylinders, approximate the volume of the drum to the nearest tenth. Okay, so first of all, if the diameter is 2.7 and we need to find the radius, we're going to have to divide by 2. So the radius is going to be 1.35. Okay, so now we use that information to write our formula. So volume is going to equal pi r squared times your height. So we're going to use 3.14 for pi, and the radius is going to be 1.35. We're going to square that times the height, which is the same as the diameter of 2.7. So in your calculators, you're going to put 3.14 times 1.35 times 1.35, because we're squaring that, times 2.7, and you're going to get 15.451, blah, 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 blah. It said to round to the nearest tenth, so we're going to make that 15 point, that 4 is going to become a 5 because it needs to round up, meters cubed. Then the last question says, how do you find the volume of a cylinder? Describe which measurements of a cylinder you need to know. Okay, well, you find area or volume of the cylinder by taking the area of the base times the height. So I'm going to write down here. Oops. You need to know the height and radius of the base. So we should probably say height of the cylinder. The height of the cylinder and the radius of the base. Okay, and then you use the formula, volume equals pi r squared times height.